All right, well, thank you all for coming. My name is Emily Nutwell. I'm the Education Manager at the Simulation Innovation Modeling Center, and Amber is our Program Manager. I'm just going to show you a real quick slide deck to explain the program, and you will be able to ask questions in the Q&A feature of the Zoom webinar. So if you have any questions, just type those in there, and we should be able to get to those. Let's go ahead and get this up and running. All right, Amber, can you see my slides?
Yes.
Okay. All right, so like I said, I'm the education manager. If you have any questions after this, feel free to email me. I will be sending out this presentation, so you'll have all this information. Amber can also take questions. Our website is listed there, as well as just a general email address if you have general questions about the SIMCenter. So program overview, these courses are focusing on the finite element principles. Most of these courses are typically offered at the graduate level, so many engineers who graduate with their bachelor's degree don't get like that formal academic exposure to finite element principles, but we know that employers value the ability to use simulation modeling. We've talked to several engineers out in industry, and they've expressed interest to engage with programs to advance their knowledge, but they need courses that are designed to work around their schedules because obviously you guys are busy with your full-time jobs. So we've designed this program for working engineers interested in learning more of the technical foundations of the finite element method to inform better modeling choices. These courses are developed and taught by, it's a collaborative effort between the SIMCenter staff as well as OSU College of Engineering faculty. It is completely online delivery, so that enables professionals to engage with the program on their own schedule. The delivery is primarily asynchronous, which means that you can log into Carmen Canvas, which is the learning management system, and those materials would be available 24/7 during the duration of the course. The course is 10 weeks long, and there's a lot of extra time built into that in case you have, well, in normal times, if you would have business travel, or if you have a particularly busy week at work, there is quite a bit of time built into the course to give you that flexibility. And the way we've designed the course is that we present the theoretical material and we pair this with actual application lectures to connect the theory to the modeling practices. These courses are designed for individuals who have some or little modeling experience, but have never taken a formal course in finite element principles. So I want to reiterate, this is not a training course. You will be required to use a finite element modeling software package. You would have the ability to choose. So a working knowledge of that would be necessary. So in order to earn the full certificate of practice, you would need to complete 3 courses. And currently, the series is comprised of 4 courses, so you have some choice. The first course, which is the one that we recommend that you start with, is the Foundations of Finite Element Principles. That really just lays the basic theoretical foundation of finite element method. And then we have linear dynamics, which is like natural frequencies, eigenvectors, those types of things. Heat conduction, as well as finite element principles of nonlinear static analysis. Each individual course the course fee is $1,000. So you don't need to apply. This is just almost more like a professional development course, so you would just pay the course fee. If you do decide to take the 3-course series, we offer that for $2,500. So again, this gives you some flexibility of if you just wanted to take 1 course, you would earn a certificate of completion for that particular course. If you want to take the whole certificate, then you would earn those certificate of completions after each course, as well as the overriding certificate. So what can you expect once you're enrolled in the course? It's delivered through the Carbon Canvas Learning Management System. So you will be given an OSU ID and login so that you can access the course. It's delivered through videos, downloadable materials, text, and all the materials are included. So you don't need to buy books or you don't need to buy anything that's outside of the course. Weekly time commitment, we're estimating about 6 to 8 hours over a total of 10 weeks. Of course, every individual is different, so there could be some wiggle room in that. Courses are delivered. The courses that we have are typically 5 or 6 modules. So you would have roughly about 2 weeks per module, and in each module you'll have fairly straightforward multiple choice quiz, a homework problem set to kind of make sure that you're understanding the concepts, as well as the class project assignment, which I mentioned earlier. That class project will work with course concepts, and since you're working professionals, we want to give you the ability to choose what you want to model so that you can pick something that's relevant to your work, that's meaningful to you. We expect most people have been using resources that are available through their work, but we have had students who have requested software and hardware resources, and we do provide that through a partnership with OSC, which is the Ohio Supercomputing Center. If you need those resources, just please reach out to us directly. That way we can get you that resource and get you set up. So for the upcoming schedule, so our upcoming courses that are coming up on August 24th, which is the first day of the fall semester, it's our first course, the Foundations in Finite Element Principles, and registration is actually open for all of these courses, but that's coming up in the next few weeks. And we have a new course, which is the Finite Element, Finite Difference Principles in Heat Conduction. So in that course, we're going to be talking about heat conduction as well as thermal stress. And we'll also get into things like implicit and explicit time integration. So we're going to just build on the concepts of the Foundations course. In January, we'll be launching another new course that which is the Nonlinear Static Analysis course. And then over the summer next year, we will offer the Finite Element Principles in Linear Dynamics. So at this point, I don't want to just keep talking. I'd really like to open it up to you guys to ask some questions. Any?
Okay, well, so far we don't have any in the Q&A or the chat windows, but we can give a few minutes. Oh, here we are. Emily, what percentage of the coursework is theoretical versus actual work within the software package of their choice?
So it's about 50-50 as far as like the quantity of the time. So for every theoretical concept that's discussed, we try to create some content as far as direct application. So the way that the assignments are designed is that the homework assignments are more conceptual. So we try to avoid like really getting into the weeds of the math, the linear algebra, the calculus. We want you to be familiar with that, but we don't expect you to do pages and pages of calculations, because we know that that's not what you guys do at work. Definitely the main assignment is the project. We want this to be very application focused because, again, this is more of a professional development course.
Okay, Emily, the question is, if we have an OSU ID from previous schooling, would we get a new one?
No.
And no, yeah.
No, we would reactivate that. So that's one of the questions that we would send out to you, is if you've already have an OSU ID, we would just reactivate that. One little bonus feature, once you have an active OSU ID, you will have access to the OSU libraries, which is a wonderful resource, which is not at all associated with the class, but it's a nice little perk that if you do have an OSU ID, for the duration that it's active, you can access OSU library resources. All right, well, it seems like we can go ahead and wrap this up. Like I said, we will share this document along with the 2 questions that were asked so that you have that resource. If you do have any questions, please feel free to reach out to either myself, Amber, or just the general email address. We will certainly respond to any questions that you might have or that you might think of after this webinar. All right. Oh, do we have another one?
Oh, yes. Okay, so the course purpose is to build a foundation, but do you have any examples from the course to share?
Examples of like a sample video? So our website probably would be a really good resource for you to look at for more direct examples of the course.
And we can maybe, when we send stuff out, maybe have a couple more, well, on the slide, there is like a screenshot from a lecture, right? Or
yeah, there is a screenshot from a lecture. So this here you're seeing examples of what a project or a homework would look like. Yeah, so this would be an example from a lecture, and then here the professor is talking about numerical integration, and then the lecture below is the application lecture where we talk about how to choose numerical integration, why we choose different things, and then looking at the results of the differences between choosing different integration schemes. If you want more specific examples, please feel free to email us. We can certainly get you examples. We're working on a video that should be posted to our website pretty soon that should have some information as well. All right. All right, well, thanks everyone for joining. We really appreciate your time. And we hope to see some of you in August. All right, thank you.
all right.